Hello, my name is Markus Kübach. I'm a postdoc at the Max Planck Institute für Eisenforschung, and today I'm very proud to show you our work on strong scaling and open source tools for analyzing atom probe tomography data in accordance with the fair data stewardship principles. Atom probe tomography is a nanoscale microscopy technique that is capable of measuring the position and mass discharge of up to 1 billion ions. However, analyzing these data at the moment faces two substantial challenges. On the one hand, most of the people in the community rely on proprietary software with black box algorithms, and much is done still in GUI interaction. On the other hand, these tools have very limited support for scientific computing. So both of these aspects pose significant barriers for reliable and performant data analyzing according to the FAIR principles. In our work, we try to change this. And therefore, we set up the following aim. First of all, we were interested in trying to improve the productivity and remove FAIR barriers in our software as much as possible. So of course, for that, we need to go with open software. The next thing we did was we developed an HDF5 alternative to the proprietary file formats, and luckily the manufacturers opted in and helped us to interface with their proprietary tools. On the other hand, we modularized all the software and developed also tools and Python scripts for automated report writing. Most of the work, though, has been devoted to the scientific computing and implementation of the key community methods and thereby developing further the tools from the community. Of course, all with open source tools. With that, we want to generate a strong set of examples to convince the community and the manufacturers that supporting open data initiatives is the way to go. So the results that we can see for our work is that we are successfully able now to compute, even for 1 or 2 billion ion dataset, analysis results that have hitherto not been accessible. On the one hand, alpha shape edge distancing, we can compute now high throughput spatial statistics and clustering, do tessellating of entire datasets, determine the crystal orientation and phase, or at least identify whether such information is present in the data. And all these tools scale now on CPUs as well as GPUs for up to 3200 cores. And I'm very happy that this work has been powered by the Big Max initiative, in particular by the Taylor's cluster. So the next step of our work is we want to interface our tools with Python and Jupyter workflow management software, and hopefully within the key German NFDI consortium FAIRMAT, we want to interface and contribute with our expertise on atom probe and want to assist also all the other experimentalists in developing together a workflow organization software and contribute to building a global materials encyclopedia that includes atom probe tomography experiments. So I'm very happy to talk with you and learn from you, as well as to share our experiences that we had on scientific computing, as well as on atom probe tomography. And with that, I hope we see you online. Thank you.